Now we'll see the introduction about the signal. Anything that carries information is called a signal. The signal is varying with respect to time. The x-axis will be time and y-axis will be amplitude. This is an example of signal. There are two examples given. One is the speech signal and another one is ECG signal. You can see both the signal, the x-axis is time and y-axis is the voltage. Signals are of two types. One is continuous time signal and another one is discrete time signals. The upper one is the continuous time signals and the lower one is the discrete time signals. Continuous time signals will be time versus amplitude, whereas discrete signals will be samples versus amplitude. Here there is an example given for AC signal. If you see the second example, x of t is equal to 10 cos 2 pi 50 t. So if you compare with the general equation is a cos 2 pi ft. And comparing it with that, we can have it as amplitude is equal to 10, frequency is equal to 50 Hz. If you want to represent it in terms of radians per second, it is 341.4 radians per second. If you see the graph will show for one cycle, it is taking 1 by 50. The relationship between f and t is f is equal to 1 by t. So 1 by 50 will be 0.02. You can see one cycle is completed in 0.02 and the cos wave is plotted. The amplitude of the cos wave is 10 volt. This is an example of the discrete values of time. So a graph is drawn which is where the temperature is measured in a room for every 1 hour. So it is a discrete values of time. It is taken from 8 am to 12 am. So the difference of temperatures are noted down. This is just an example for showing you that. While studying about signals, you should know the basic sequence of signals. The main two basics of sequences are unit sample and unit step sequence. Unit sample sequence is represented by del of n, where it is shown in the top figure. But when n is equal to 0, the value will be 1, and when n is not equal to 0, the values will be 0. So that has been explained by equation and also explained by the graphical way. The below one is the unit step sequence. It is represented by u of n. This u of n tells that, as I told you, x-axis is n and y-axis is the amplitude. So when n is less than 0, all the values are 0. When n is greater than or equal to 0, the value will be 1. So again, this is also explained in equation and graph. This is an example of the exponential sequence. So for each and every value of a and each and every value of n, it has been plotted. It is just an example for you to understand the sample and the amplitude, how it is varying with respect to a power n for different values of k. These discrete time signals are represented in 4 ways. One is functional representation, second one is tabular representation, third one is sequence representation, and fourth is graphical representation. Functional representation is by explaining with respect to an equation something like x of n is equal to 1 for n is equal to 1 and 3 for n is equal to 2, 0 elsewhere. So if any signal is represented in this way, we call them as functional representation. And if you see to the tabular representation, it is written in table. So any function, the same function in the above example is now represented in tabular form. So a signal can be represented in any of these 4 ways, and I always recommend my students to make use of tabular representation, which will be useful for you to understand more about the signal. come to the third representation, sequence representation, where it is represented as x of n, which is equal to, in the curly bracket we have the values, and you can see an arrow mark below that represent, that is the value at n is equal to 0. So the values which is coming after that arrow, the right side of that arrow represent for n is equal to 1, 2, 3 and positive values of n. The values in the left hand side of the arrow mark will be for negative values of n. So n is equal to -1, -2 and so on. So this is the sequence representation, and the same thing if I represent it by a graph, taking n in the x-axis and taking x of n, whatever it may be, in the y-axis, and we draw the graph, then that type of representation we call it as graphical representation. So any of the representation will be given, and you are supposed to understand how you can retrieve the signal by any of these four representation. So basic operation, there are three main basic operation of the discrete signals. One is folding, shifting and time scaling. So there is an example. Now if you see folding, if n is replaced by -n, we have x of n, and if we write x of -n, when we compare the output of x of n and x of -n, then we can see that it is folded. We tell that the mirror image, or we tell it as folded. Then comes the shifting. When we have x of n is the input signal and x of n minus k or x of n plus k, where k may be any integer value, any positive or negative integer value, then we call it as a shifting. Scaling is if n is changed by kn. If we change the value of n by kn, then it is scaling. So this is compressing or dilating a signal.